Okay, so 6.5, we're assessing normality. Some of this will be review because we have talked about it. The last part will be the new part because we're actually going to create a normal quantile plot. So just to review what a normal distribution is, the two characteristics about it that we really need to make sure it's locked in our memory. Normal distribution is bell-shaped for one. And then bell-shaped could either mean like it increases and decreases like that or like that. So then we'll also put the second criteria that it increases and then decreases, just so we eliminate this second graph over here because that shouldn't be an option. Okay, so now that we remember normal distribution, this is the two things that we absolutely need. A normal quantile plot is basically like a scatter plot that shows whether whether a graph is normally distributed. That was a hot mess. Okay, so this is a scatter plot showing whether, see, I missed the word, a histogram is normally distributed. This is how we started like the whole semester, is with histograms because we had to graph our data. Histogram, remember, is like one of these things. So like that is normally distributed because it follows a normal distribution curve. Okay, so when we did this, we actually saw scatter plots about the histogram. And the two things that we had to check out were, do the data appear to be aligned? Holy cow. Words today are a challenge. But then there's some that look like straight lines, but then they're not actually normally distributed. So our data cannot have a pattern. Okay. And like I said, we'll eventually graph normal quantile plots. So that way you understand why the heck we are looking at this data to figure out whether the histogram is normally distributed or not. So to start, we have the first normal quantile plot. So I'm just looking at these scatter plots. Does it appear that all these data values appear to be a straight line? And we should say, yes, they do look like they're a straight line. So that means it's normally distributed. And we did do this, I can't remember what chapter it was, like chapter 1 or 2. So this should be review, analyzing these kind of normal quantile plots. This one, if I followed all these points with my pencil, it actually appears like that. So it does not follow a straight line pattern. So this is not normally distributed. And I believe this is actually skewed. I just can't remember if it's skewed to the left or to the right. And then our last one, same thing. So if I followed all these points with my pencil, it would look something like that. So this one's kind of hazy. Kind of, I would say maybe it looks like there's a pattern, like it kind of looks like a cubic, like something like that. So I would say this is not normally distributed. Technically, if it does appear like this, all of the scatter plot points, this is a uniform distribution. Not sure why, but that's just what it is. Okay, so like I said, we're actually going to be creating these scatter plots. So there's steps to actually do this. There's 5 steps that we're going to follow, and we're going to do this for one example because it's kind of a process. So step number 1, we're going to order our data from least to greatest. Step number 2 is kind of weird, but it kind of makes sense because we want to figure out if it's normally distributed. So if I was given a normal distribution curve, technically I want to split this normal distribution curve into equal slices So that way my data can line up equally along the normal distribution curve. So like we're gonna cut it into these random slices that are equally spaced. And there's a reason and a formula to try and get this equally spaced. Because technically I cut it into 1, 2, 3, 4, 5 parts. So that means there's like 5 data values. Okay, so I'm gonna say find proportions slash areas to the left by using. So our formula is like 1 over 2 times n. That's our first proportion, and then I have 3 over 2 times n. That's my second proportion, 5 over 2 times n, etc., etc., where n is our sample size. Okay. Oh, jeepers, I'm running out of space. Step number 3. So we're going to find the z-scores for the proportions in step 2. Step number 4, we're going to pair the data with z-scores. And then we're going to graph and analyze. Okay. All right, so we're going to do this with our Old Faithful. So it says, let's consider the sample of 5 eruption times of the Old Faithful geyser. So I have those 5 data values. Construct a normal quantile plot for these 5 values and determine whether they appear to come from a population that is normally distributed. So we're going to go through all 5 steps here. So step number 1, I want to order the data from least to greatest. So 125 is the smallest, 229, 234, 236, 257. Okay, step number 2. So I'm going to cut my normal distribution curve into slices. So since our n value is 5, because I have 5 data values, I have 1 over 2 times 5, 3 over 2 times 5, 5 over 2 times 5, 7 over 2 times 5, and 9 over 2 times 5. And I should have 5 proportions for my 5 data values. So these actually become 1/10, 3/10, 5/10, 7/10, 9/10. So basically, if I actually did a normal distribution, just so visualize here. So basically, they would cut it here and say 1/10 of the data is to the left of that line. So this area is 0.1. If I did 0.3, 3/10, then maybe 3/10 of the data falls to the left all the way to the left. So that area is 0.3. And then, if I kept going, so here's 0.5, half the data is to the left of that. That's what all of those proportions are really demonstrating. So I actually want to find all the z-scores. So I have a z-score at that dividing line, that dividing line, that dividing line, and then here and here. So we want to figure out all of those data values. So if you remember, if I'm given an area and I want to find a z-score, we're actually using inverse norm on our calculator to calculate the z-score. And we did do that in section 1 and 2, I believe. When we do inverse norm, we're using the standard normal distribution. So the mean is 0 and the standard deviation is 1. Okay, so if I type this in here, my first z-score that corresponds to 1/10 is negative 1.28 here. And remember, z-scores, we always round to the nearest hundredth. If I do the next one, I get negative 0.52. My next z-score is 0. The next one, 0.52. And 1.28. I mean, honestly, that would take a lot longer to type in all 5 of those in your graphing calculator. I just knew them off from doing this before. But you'd have to do inverse norm for all 5 of those. So area of 0.1 to start, and then area of 0.3 for the second, area of 0.5 for the next, 0.7, 0.9 to get all 5 of these z-scores. I just don't want to waste your time sitting with my calculator here. Step number 3, we are pairing our data value with our z-score, and it's always data value is x, our z-score is y. So we ordered our data for a reason, because our smallest data value should correspond to our least z-score, which is negative 1.28. Our next smallest data value should correspond to the next z-score, and so on and so forth. So I have all of these wonderful points, and we'll have to graph this as well. And when you graph, it doesn't matter where you start on the x or y axis. You could break the x-axis and start at 125 if you wanted to, which is what I'm going to do. So I'm going to count by 25. So that's 125, 150, 200. And you want to make sure your graph is evenly spaced, and mine is a sad depiction there. And then I think on my y-axis, I'm going to count by 0.25s. So that's 0.5, 1, and then 1.5. And then same thing down. Okay, so then graphing this. We have one there, 229, 234, and 257. Oh gosh. Maybe like right there. So I mean, okay, if I'm looking at this, I would say this is not normally distributed because these points do not appear to be a straight line. If I would actually eliminate that data value, I would probably say these other 4 appear to be a straight line, so then it would be a normal distribution graph for those 4 data values. But it's not. And that's all we got. So this, what we just graphed, that scatter plot, that's our normal quantile plot. And that's just telling me if it's normally distributed or not. And it doesn't appear to be a straight line, so it's not. And that's all we're doing today.